of it was part of him, and by letting him be who he was, I could be who I was.
By November of 1998, Osman was looking forward to slowing down and enjoying his family life. He had been pushing hard for many months. He decided to make a final record-breaking fall from Yosemite's Leaning Tower. Assisted by Miles Dasher, Osman packed over 1,000 pounds of equipment to the top of the tower. It took him 5 days to prepare the specialized rigging that he had designed for the jump. A local filmmaker videotaped Dan's thoughts just days before the leap.
Really, it's about adrenaline and having fun with it, and just kind of scaring myself in some sick sort of way.
Dan completed a successful 1,125-foot jump on November 22nd. Miles had a successful jump the next day. It was dusk by the time he hiked back up to join Osman.
When I arrived up top, Dano, he was just racing to rush and get it dialed in, and he's trying to tell me that he wants to jump before it gets dark. And I say, I don't think you're going to be able to do that because we got to do this check. And I'm trying to slow him down, you know, don't worry about it. You're not going to get it in the daytime. It's going to be dark.
Dan was convinced that he could push his system just a little bit further. An additional 75 feet would create a record 1,200-foot self-arrested free fall. In order to do this, he would have to drop into a channel between the wall of the cliff and the pine trees beside it.
My biggest fear in this leaning tower jump is hitting these 150-foot high pine trees. The reason being is that I'm pushing this jump so far to the deck that these trees are obstacles. What I need to do is target my flight in between the trees so that I don't hit them, because I'm going to be coming in hot below the tree line.
That kind of scared me, just thinking, you know, wow, you're going past the treetops. You better make sure you nail your mark.
The light was fading quickly, and Osman needed light so he could direct himself into the narrow drop zone. Osman hurried through his system checks, took his position on the edge of the cliff, pulled out his cell phone and dialed.
So we got a call later that evening, sunset, dusk, and it's Dan saying, okay, you guys ready? Oh, geez, he's going again, you know. So he says, okay, you know, you got me, Miles? 5, 4, 3, 2. Great exit. You know, pumped it out there chest high, started slowly rolling it over into the delta. So he jumped off, and I could hear the wind build up in the phone at my house here. And I was counting his delay, you know, 5, 6, 7, 8, 9, 10, 11, 12, and the phone cut off. And I was like, whoa. And you see his headlights start to disappear off into the darkness. Next thing you know, I just heard a brief yell, and a tree, sounded like a tree broke in half.
Miles climbed down from the tower and found Dan lying under some broken tree limbs.
And I checked his pulse, and I shook him, and I'm like, Daniel, talk to me. Come on, Daniel. And just nothing. He was definitely not with us. And I gave a little prayer on him.
The rope had shredded, killing Dan on impact.
I know things in life go the way they're meant to be, and Dan's life was so the way it was supposed to be. I'm sad for me. I'm sad for Emma. I'm sad for Dan's family and his friends. But I'm not sad for Dan because he had the life.
Wow. All right, guys, so it's not like Disney, right? He didn't survive. That was sad. Here's a question for you. Did he die on impact, or did he survive the impact? What do you guys think? Do you think he died on impact, or do you think he actually survived the impact? Do you think this is something that you can survive?
There's branches that can absorb the impact. He might, but.
Okay, Christian, I'm going to give you 5 points for that one. I mean, obviously he collides with one of the branches, right? So what happens to the tree? That branch, whatever he hit, ended up breaking. So that certainly increases the impact time. So do you think he survived the initial impact and then died because of the internal bleeding, or do you think he just simply was dead upon impact? This is a sad story. All right, so this is a pendulum move. This guy is actually really, really famous, evidently.
Did he really end up with no leg, no foot, and his intestines all over the place?
Okay, hold that question. All right, hold that question, my man. All right, so let's do this. I'm going to give you a setup for this one. All right, so he's got a cable. And this cable is 1,200 feet in length. Okay, so he anchors it somewhere. He just walks to the side just a little bit. And then he jumps. Okay, so when he jumps, what's going to happen is this cable is going to stretch. And then it's going to become taut. All right, so he's going to do a direct jump like this. All right, so it's going to become really tight. And then boom, it turns into a pendulum move. Right here. All right, so this is what's going on, and then he's going sideways. So the question is, how fast was he going at the time this accident happened, right? All right, so it's going to be a direct jump. So the one thing that we know is the final height is going to be at the bottom. The lowest point of motion, I'm going to take this to be the final height. I do that, it's called experience. Because the potential energy is always measured relative to some kind of a ground. In this case, I'm just going to take it to be the lowest point in motion. All right, so this is the initial height. Initial height is going to be measure with respect to the lowest point in motion. So this is going to be 259 feet. Nope, this is 1,200 feet. 1,200 feet. Okay, so 1,200 feet is the length of the cable.
This was originally said in the video?
I hope so, yeah. All right, so the final height is going to be 0. Yeah, he was using a 1,200 feet long cable. 1,200 feet, remember, guys, if you go to the top of the Sears Tower, it's going to be 1,450 feet. All right, so this is 1,200 feet. All right, so his initial speed at this point it's going to be 0. I'm going to make this 0. Okay, so we're trying to figure out his final speed. And then we'll do an impact analysis. Just for the final. Yeah, what else do we have? Okay, that's it. Gravity is the only force acting, right? Okay, so we will be ignoring the air friction. Because we're ignoring the air friction, gravity is the only force that's going to be acting on the system. All right, so G is acting on it. So here's the initial mechanical energy. This one is the final one. Okay, so 1,200 feet converted to meters is going to be 365.85. All right, 365.85. That's what we got. Okay. If gravity is the only force acting, obviously mechanical energy is going to remain constant. All right, so the final as well as the initial mechanical energies will be the same. All right, so which means that it's a combination of kinetic and potential energies, guys. So here's the formula for you. All right, so here's the final kinetic energy, final potential energy, initial kinetic energy, and initial potential energy. Okay, algebra is the same as before, so I'm not going to change. I'm not changing anything. All right, so what do you know? The initial speed is going to be 0, and then final height is going to be 0. All right, so this is going to go to 0. This is going to go to 0. All right, so final height is 0, so this goes to 0. So is this one. So we got 1/2 mv squared equaling mg times the initial height. Get rid of 2. Get rid of the mass. All right, so that gives you an expression for the speed, final speed. And then get rid of this square. Okay, conclusion is straightforward. Notice that higher the initial height is, the faster you're going to hit the ground. That's what it means. Higher up you go, the faster your speed is going to be. All right, and then you plug your numbers in. It should give you 85.53 meters per second squared. Converted to miles per hour. This is about 190 miles per hour. All right, so this person will be hitting the tree branch at 190 miles per hour. So that's your random. Okay, guys, it's not how fast you're going that matters. It's how fast you come to a stop, right? Okay, so what that means is we have to do impact analysis. So this guy is literally going to hit the tree branch at 190 miles per hour, and the branch is going to break. It's going to break. Because it's breaking, there's usually impact time involved. Normally, I would give him 1/10 of a second because the tree branch is breaking, but I got news for you. 1/10 of a second is something that I would give anyone if a tree branch is breaking. At 40 to 50 miles per hour, not 190 miles per hour. At 190 miles per hour, I don't think so. The best that I could do for him, and I'm going to negotiate because I'm from Middle East, like the haggle, the best I could give him is 100th of a second. I won't be able to give him more than that. All right. This speed is way too fast. All right. I'll give him 100th of a second. That's a reasonable impact.
How about 99th of a second?
Oh, no, that's not. You got to be reasonable. All right. I'm thinking, yeah, let's not negotiate that one. All right. So I'll give him, where am I? All right. I want to add a page. All right. I'll rough estimate at this point. Impact time is going to be. All right. So let's do the impact analysis. All right. So this guy is coming down. He's doing a pendulum move. Impact is going to start right at this moment. All right. So he's going to be hitting something here right at this moment. And he's moving in this direction. Okay, so his final speed in pendulum mode, which is this speed, becomes the initial speed in impact, right? So this is 85.53 meters per second. And then I'm going to give him an impact time, estimated impact time. I cannot give him more than 100th of a second. That's the best that I could do because this guy's going way too fast. All right, and the branch is going to break, or tree top. I don't know what broke. I don't remember. And then I'm going to make the assumption that he comes to a complete stop at this point. More than likely, he's going to keep moving a little bit. He will slow down quite a bit, but this is an estimate. Just want to check to see if this guy actually suffered from any pain. Okay, was he alive at the end of the impact? Okay, that's what I'm investigating. All right, so obviously the body is going to go through jerky motion. Okay, this is known as the back of the envelope physics. That's the sort of stuff that I'm teaching you here, in essence. So you can run quick analysis. All these real life examples will help you with your engineering. All right, so, okay, so let's check to see what happened to his acceleration. So here's the formula.
8,553.
Final speed is going to be, and then this is going to be, yeah, and that's going to be 8,553 in negative. Very good. Meters per second squared. Reverse out 5 points for that one. And then I'll move the decimal to the left to come up with the acceleration. So it's going to be around 850 Gs. Okay, so do you think this is survivable?
No.
Not a chance.
Do you think he survived the initial impact? Okay, so the answer to that question is no. Yeah. All right, so the answer to that question is no. This guy didn't survive the initial impact. Okay, but let's hold. Okay, this is an estimate. All right, so this is dead upon impact, right? Okay. All right, so this is dead upon impact. All right, so now let's go back and do a realistic assessment. Okay, this is 250 Gs. All right, so ignore friction, that's what you will come up with. So including friction, what do you think is going to happen? Including friction, what are you looking at? Including friction, 120 miles per hour is the terminal velocity. Depending upon your body position, you can probably go up to 160. So 190 is probably not reasonable. 160 is more like it. And then he won't be coming to a stop immediately after hitting the tree. Don't forget that. So 850 Gs is probably the maximum acceleration that he's going to suffer. So I'm just going to make it more realistic. The more realistic is probably going to be 500 to 600 Gs. Again, guys, it's dead upon impact. Okay, it's just dead upon impact. That's it. He did not survive the impact. He did not survive the impact. It's just not survivable. Accident scene and all that stuff, I just made it up. I have no idea in what condition his body was. Okay. The only thing I can tell you is there's no way he actually survived the initial impact. He was never conscious after that. As soon as there was contact, that was the extent of it.